Hi guys, this is Arpana from Sri Venkateshwara College of Engineering of Electronics and Communication Engineering. Today I am here to discuss the topic illustrate with examples the automatic instructions which are available in the 8051 instruction set. Introduction. The 8051 instruction set which will be including a variety of the automatic instructions in order to perform the mathematical operations. These instructions are essential for the manipulating the data within a microcontroller. Automatic instructions which will be helping in addition, subtraction, multiplication, and also dividing the data stored in the registers. Even the 8051 microcontroller architecture will be also including a set of automatic instructions that will be operating on data stored in its registers as well as in the memory. So as we can observe in this image, there are many arithmetic operations like addition, subtraction, the two addition with carry, subtraction with borrow, incrementation, decrementation, and multiplication, division, and also decimal adjust accumulator. First is addition operation. So add, which is nothing but a general name for a set of SC11 addition instructions we will be using, and the destination will be address. But the destination for the address, it must be a register or accumulator. The add a comma as data, which is the instruction I am giving. So it will be adding the accumulator a with an immediate data value. For example, add a comma as 25. Here a is the destination, whereas as 25 is the source. It will be adding the 25 to the accumulator A, so that the A is equals to 25 value it will be becoming. For the result will be, if I am giving A is equals to 10, already A is having a 25 contents and I am adding that 10 to that. After the execution, the A will become the 35. Like that, the example 2, add A comma or register 2. That is nothing but it will, whatever the contents of register auto is have, it will be added to the accumulator A. So there are few examples for the addition instruction. As we can see here, for addressing modes for RAM and inherit addressing. Even there are indirect addressing as well as a direct addressing for the addition of instructions. Add a comma rn, which is a register addition. So add a comma rn, it is also one of the instructions which will be adding the accumulator a with the value which will be specified with the register or n. For example, add a comma r2, it will be adding the values in the register r2 to the accumulator a. Result, if a is equals to 10, then and r2 is equals to 5, after the execution a will become 0 or 15 becomes, because why means I am adding the whatever the contents are that r2 that to the a accumulator, so that a is equals to 10, r2 is equals to 5 means if I am adding both, then I will be getting a is equals to 15. So there are few logic instructions like adding the register to accumulator, and adding direct byte to accumulator, indirect RAM to accumulator, or register to accumulator, or direct byte to accumulator. There are many instructions like that. Add a, which is a direct addressing addition. So it will be adding the accumulator a with the value which will be stored at a direct memory address. For example, I am taking add a comma 30h will 30h. So it will be adding the values at the address 30h to the accumulator, so that a will become z 30. For result, if a is equals to 10 and the value at address 30h is equals to 10 20. So after the execution, what will the a value will become 30. Why means I'm adding the a 30h values to the a. That is nothing but I'm taking the value of a is equals to 10 and 30h value I'm taking 20. So if I'm adding both, then I will be getting the value a is equals to 30. So sub a comma as data, subtraction with the barrow. Subtraction a comma as data, which is also an instruction which will be subtracting the immediate value from the accumulator a with the barrow. For example, sub a comma as 20, as 5. it will be subtracting A from the accumulator A along with the borrow. Result, if A is equals to 10 means there is a borrow after the execution, then A will be becoming a 4. So as we can see here, there are a few examples like sub A comma as data, A sub A comma direct, sub A comma at or I where I is equals to 0 or 1. So like that few examples. If there is no borrow means A is equals to A minus O, so direct we can take. If there is a borrow means then the accumulator value will becomes like A minus source minus carry. That is nothing but the borrow. Even there is a note like the 8051 uses the two's complement method in order to do the subtraction. So after the execution, whatever the C flag is there, it will be set to 1 if the borrow is needed into the bits 11. And the AC flag will be set to the 1 if a borrow is needed into the bit 3 value. Then sub A comma Rn, which is nothing but register subtraction with the borrow. And it is also an instruction that will be subtracting the value which will be specified in the register Rn from the accumulator along with the borrow. For example, sub A comma R3, it will be subtracting the values which are in the register R3 from the accumulator along with the borrow. The result will be if I am taking A is equals to 10 and register R3 value is equals to 3, and I am assuming that there is a borrow. So after the execution, A will be getting a 6 value. So as shown in the previous image, there is a formula for the borrow. So if you are applying that formula, then we will be getting the A value. Then here also there are one of the two arithmetic instructions like DA, which is nothing but the decimal adjust the accumulator. So it is a format the accumulator into proper two-digit packet BCD number, and it will be operates only on the accumulator, works only after the addition instruction only. And subtraction with the borrow, subtract an operand and the previous value of the borrow, which is nothing but the carry flag from the accumulator. The result will be always saved in the accumulator. Sub A comma direct, which is a direct addressing subtraction with the borrow. And here it will be subtracting the value which will be stored at a direct memory address from the accumulator A with the borrow. For example, sub A comma 40H. So 40H is the address, and here I am taking the whatever the values will be there, it will be subtracting from the accumulator A along with the borrow, because we are considering the subtraction along with the borrow, so we will be taking the borrow. Result, if A is equals to 10, so the 40H value I will be assuming as a 8 and A value I will be assuming as a 10, and there is a borrow. After the execution, I will be getting A value as a 1. Mul A B, which is nothing but a multiply accumulator A and B, which is a multiplication instruction. So the mul A B instruction, which is nothing but it will be multiplying the accumulator A by the B register. So for example, mul A B, it will be multiply the values of the A accumulator and B. Result like if A, now I am assuming like A is equals to 5 and B is equals to 3. So after the execution, A will be gives rise to 50, which is nothing but a multiplication how we will be doing in the mathematics. That's it. And here also, here in multiplication, like we can take even signed as well as the unsigned numbers also. And divide accumulator A by B, which is nothing but division, and it will be dividing the accumulator A by the B register. For example, div AB, which is an instruction I will be taking. So it will be divide the values in the accumulator by the B. So result I'm taking like I'm assuming if A is equals to 10, 20 and B is equals to 5. So after the exhibition, I will be getting A is equals to 5, because what I am taking A is equals to A by B. So 20 divided by 5 is 5 4s are 20. So what the value I am getting? 4 as the value. So the accumulator is the destination. I need the destination value. So A is equals to 4. The value I is getting. So this is a simple division which will be as we can as we are doing in the mathematics, we can do here itself. And increment A, which will be represented as INCA. So which will be if increment is nothing but increasing the values. It is also one of the instruction which will be incrementing the value in the accumulator A by adding 1. For example, in INC A will increase the value by accumulator A by 1. So for example, I'm taking result. If A is equals to 5, so I'm assuming that A value is equals to 5. So after the execution, A will become 6, nothing but A is the destination. I need the A value. So I'm taking, assuming A is equals to 5. I'm incrementing is nothing but increasing the value by 1. So 5 plus 1 is equals to 6. So A will be getting as a 6. And here also we can observe here there also incrementation takes place. And the next one is DECA, which is nothing but a decrement accumulator A. And it is also one of the instruction which will be decrements the value in the accumulator A by 1. For example, DECA, it will be decreasing the value in accumulator A by 1. And like if I'm assuming A is equals to 8. After execution, what the main decrement point means to decrease the value by 1. So 8 minus 1 means it will be 7. So the value of the A we will be getting after the execution is 7. So summary of the arithmetic instruction, the IT51 instruction set, it will be providing a range of the arithmetic instructions in order to perform the mathematical operations. And these instructions which are crucial for manipulating the data efficiently within the microcontroller. Understanding as well as utilizing these arithmetic instructions, that too in the programming language, which is essential for the 8051 microcontroller. So thank you for giving such an opportunity to explain about the topic of the instruction sets which are included in the 8051 microcontroller.